I'm going to talk about robot model development, and hopefully by the end of this talk I'll convince you that with Phobos it might be development on steroids. So when I started to work at the University of Bremen 2 years ago, one of the first assignments I got was I had to build a UDF model for our shiny new robot, the Mantis. And you can see that's Mantis, so it's a really complex walking robot with 6 legs and many, many degrees of freedom. And the UDF is rather complicated. I mean, this is not the entire UDF. That's not the entire UDF. And you can see even my computer is kind of breaking down because it's just too much. This finally is the entire UDF, and I guess you can't really see it anymore, but if you can't see Mantis anymore, that's kind of the point. It's just that much. And there was no way I was going to write this by hand, as I guess many of people who use ROS still do. So I figured I have to come up with a way to kind of avoid that problem. And that way ultimately became Phobos. So there's already ways to kind of mitigate this problem. And there's, for example, Xacro, which lets you kind of reuse part of your UDF that you've already coded, but it still, well, requires you to code something yourself. And then you have stuff like plugins for SolidWorks that exports the general kinematics to UDF. But most of these, and I think that includes what the ROS industrial guys were talking about, this Cat2ROS. And we have another tool at our institute called Cat2Sim, so this idea has kind of been repeated a couple of times. But they all include the engineers tinkering with the CAD drawing a bit, and these people don't usually like that. And also, if you don't happen to have SolidWorks, which is a rather expensive piece of software, because you're building a robot in your garage or something, then that's also not really ideal. I mean, this is all about open source, right? So the tools should be free and open source. So what really is Phobos? Phobos is an add-on for the 3D modeling software Blender. And it happens to be free and open source. And originally, we started developing it for our own simulation tool, which is called Mars, and both of them you can actually get on GitHub. Now, this leads us to the next question: what is Blender? So Blender is a 3D modeling tool, comparable to 3ds Max or Cinema 4D. It's really comprehensive. You can do all the modeling you need. You can do geometry, you can create materials, you can even do animations. And for animations, it has something really useful called armatures, which are kind of like you can think of it as like kinematic skeletons for your animated characters, something we're going to use later. And it's also free and open source, which is really a nice coincidence. And it runs on all major platforms, so anybody can really use it anywhere. And it has a really nice and almost complete Python scripting API. So anything you can do in Blender by clicking and stuff, you can actually also script using Python. And that's something we can make use of. So when you look at what UDF consists of, like the elements you have, and what you have in Blender, we actually see some nice parallels. So in UDF you have links, which are kind of reference frames in your models, and then you have joints, which both define the relation, like the spatial relation between those reference frames, and also how these reference frames then can move, how they are constrained. And also you have visual and collision objects, which get attached to the links, so they exist in their reference frames, to be able to represent the visual model of the robot and the collisions. And in Blender you have pretty similar stuff. I mean, you have these armatures and bones, which are part of these kinematic animation skeletons. And you have geometric objects which could represent visual and collision objects. So if we take a look at what we actually have in Blender, you have these bones, and each of those has its own armature. So basically, any one of those things you see here, you have to think of as a link in UDF. And basically, the way the joint is defined, you can see from the orientation. So you have these bones, and the long axis of that bone is the rotation axis of your joint. Or if you have a linear joint, it's the sliding axis. And so by just arranging these bones, these links, the way we can basically build a kinematic skeleton. And in this case, for the Space Climber robot, which is one of our robots. And we just added the visuals, so that's the visual representations we have. Then we have on another layer, we have collision objects, and we can all put it together in a complete model, including sensors, and whatever you want in there. Also, if you look at the way Blender structures these models, they are kind of hierarchically structured, just in a similar fashion as they are in UDF. So you have these trees, and if we now break up this link here, what we can see is that we directly attach both the visual and the collision geometries to that link, so they exist in the relative reference frame. And you can even put the next link relative to the top link. So basically, the exact same structure that you have in UDF, you can also represent in Blender. And so what you effectively get when you work in Blender to create your UDF models is you have like what you see is what you get experience, right? So you can, well, you start with your robot, and this is not working, all right? You start with your robot, and you can basically, from whatever way, whether you build it from scratch or you get it from CAD, you can then import it into Blender. You separate the visuals you get, because that's the actual geometry of the robot. Then you can create, using the bounding boxes of these visuals, the collision objects, and you can even refine them, creating multiple collision objects depending on how detailed you want to have it. I really hope you can actually see this. And well, then you have the final model, and what you see in Blender is exactly what you're going to export and later use in whatever tools you want to use UDF with. So, but I just said, how do you import it from CAD? Well, there's multiple ways. You can start with one of the tools I mentioned earlier, and simply import the UDF which already exists into Blender, and using Phobos to refine it and to add all the other stuff. But what you can also do, if you don't want to like, prep your CAD models for that process, you can actually simply export all the visuals you have, like all the elements, from CAD in the same reference space, using STL files or Velma files. And if you then import it into Blender, because Blender can read all these formats, they basically, all the elements are going to be placed correctly with respect to one another. And what you can do then is you just basically select them all, then you change the center of the center points, the origins of each and every object to the geometric center of mass, and then you can start working with that. You can start adding your links and building your model. So that's basically the interface of Blender, and we already talked about the hierarchy of objects up there. And what we did for Phobos, so we created this add-on, which adds a whole new toolbar to the whole interface here. And that's this toolbar. So here you have buttons to create links, you have buttons to create collision geometries, you can attach motors, you can attach sensors, all these cool things to kind of make your model a really functional UDF model you have there. And what you don't have there, what we forgot, or what might be like tinkering to your own specific needs, you can actually do yourself, because we have scripting in Blender. You can write your own Python scripts and manipulate all the properties of all the objects. So whatever we forgot, you can script it, and if it's really cool, you can actually just give us a pull request, and maybe we'll just include it. Another feature that's really, really cool about Blender is that all the individual objects have their set of nice custom properties. So think of this as a Python dictionary that is attached to every single object in Blender. So that enables you to effectively take any property you want, any number, strings, you can even put in whole dictionaries in there, and attach it to these objects. So for example, in this case, we have this link up here, which at the same time, remember, is the joint, right? And we basically attach the motor by defining the maximum effort and speed of that motor, and by defining PID values for the controller. So everything really you need to know about your model can be represented in Blender, and it's a really cool tool for that kind of modeling. So I mentioned all these custom properties, so what do we actually do with it? Well, because I mean, you have this representation in Blender of all these different objects, and it's rather a bit clunky. So what we do is we create a Python dictionary where we take all the information, put it in one place, and then we can use that as a kind of interface for import and export. So if you want to export to another format, or you want to import from another format, you don't need to know anything about Phobos. You just need to know how this dictionary is defined, and you can write your export script. So it's really nicely manageable. And also allows you to define new components like sensors, for example, which you can then just import and putting in that dictionary structure. And of course, it also simplifies debugging. And for that, to be able to represent all this information, we actually extended UDF, because UDF doesn't really support sensors and motors that well. And so what we did, we thought, okay, let's keep UDF for the kinematics and then add all the other information in an extended format, which we like to call SMURF, what just happens to mean the supplementable, mostly universal robot format. And so what we do is we have this kind of hierarchy of files. where you have a UDF, and then accompanying it, there are YAML files. YAML is a lot nicer to read, right, than XML. And where you can define sensors. For example, you have a sensor that's attached to a link, or you have a motor which is attached to a join. So you can basically annotate your UDF without making a big mess with lots and lots of custom tags that nobody else will be able to read. So we have basically compatibility with UDF, but we can attach anything we want. So that's Smurf. And you don't have to stop there, right? Because you have one Smurf in Blender, and then you have a second Smurf in Blender somewhere else in the same scene. So you already have the information of where these two robots are oriented with respect to one another. So you can basically, just by taking the global positions of these robots, export them into a scene. And then by using UDF joints, like floating or fixed, whatever you want, to attach it to the scene, you can basically build a whole scene file. And we don't yet export to SDF for Gazebo, but we'd really hope that somebody might want to do that at some point. So really at the moment, how we think of Phobos is this kind of upstream tool. So you get your model in there, you export it to your UDF and Smurf, and that's pretty much it. We have some functionality already, where you can, if you have an updated version of your UDF, kind of gather information back and change things around a bit, but it's still a bit experimental, so to speak. It has a nice pro that you have all the information in one place, but at the same time, Blender files are binaries, so you have the problem that you really cannot create branches and merge back. We were thinking about just exporting this whole Python dictionary and then importing all the information from there again to be able to make it nice and put it under version control, but that's also still something for the future. So that's basically Smurf and how we extended UDF. And well, let's talk about current development, because I think I'm running out of time here. So we are on GitHub, as I said. So it's all free, it's open source. You can get it, you can fork it, you can work on it if you want. And we also have quite a lot of documentation already in place. So in the wiki, we have sort of a user manual. And on our GitHub pages, we have the code documentation, although I think it's a bit outdated at the moment, to be honest. But we're working on that, and we're also working on fully support the entire definition of UDF, because, for example, mimic joins are yet not really completely supported. And also we have a problem in that because we were developing this for our own simulation, we had quite a lot of historic baggage of all these parameters we put in these models. So the Python dictionary at the moment really represents kind of intermediate place where you have some definitions already nicely in place, but some other stuff we just basically dump it in YAML just the way we use it in Mars in our simulation. So moving on, we definitely have to standardize this and specify it for everybody to be usable. And of course, if you want to take part in that, contributors are always welcome. And with that, I'd like to thank my contributors so far, my two students who've been working on this for the past year, and the guys who funded us at DLR. And I'm happy to take your questions. So the question was if we have any tools to reduce the model sizes, because the geometries you get from CAD are really, really complex. And yes, we do. It's because Blender is so awesome. So basically in Blender you have modifiers you can attach, you can apply to these geometries that will reduce the amount of vertices in there. So we have like a typical robot. If you say you start with like 100 megabytes that you get from exported geometry from CAD, we can break it down to probably 10. Depending on the geometry. So the question is, if we already have the animation capability in Blender, if we also can use that to kind of have a live representation of the robot moving. And yes, we thought about that, but I mean, we already have a simulation that we use for lots of applications. And but there's actually people who do that. There's a project called Morse, where they use Blender, because Blender also has a physical simulation engine, I think it's Bullet, where they actually simulate robots in Blender. I mean, what I think is really nice about animation, though, is you can, if you already have your robot in Blender and you can animate it, I mean, it's always nice for public relation material, right?
One more?
Yeah. So obviously Blender is a good solution because it's open source, and providing open source tools for open source middleware is great. Why don't you look into something like free CAD, free CAD?
Well,
it's like a solid geometry kernel, and you do not work on meshes from the onset, but you just export your solid geometry to meshes later on.
Well, that's the thing, right? I mean, we really wanted to reduce the number of tools you needed to use. I mean, we wanted to be able to have somebody just using this one tool to do all the robot modeling work they need. And if you then start with FreeCAD and you export it again, then you still need to go through this transition of just changing all your meshes around. And yeah, that's pretty much the answer.